This is Joe, and this is my project titled Using Arduino to Explore Action and Perception, where I asked one question: does control over color change our perception of color? I used some simple softwares to do this, including Processing, which is completely free, and Arduino, which is completely free. And to interface with Arduino, I used an Arduino Uno, which is around $25. I used a breadboard, a potentiometer, and some wires, which should run less than $15. And shown here is the simple circuit I used with the Arduino on the right and the breadboard on the left. A simple 3-wire circuit with a potentiometer is all I needed for an analog input into Processing. As mentioned earlier, I used Processing with this project and interfaced Arduino with Processing so that people could change color in front of them in lifetime. Now, people were shown 4 colors, 2 colors on the right and 2 colors on the left, and their task was to match the colors on the right to the colors on the left. However, the order of the colors changed between trials. In total, subjects had to match colors on the right-hand side, the outsides, the insides, and then the left-handed sides of screen pairs. Now, color matching happened via one of 2 mechanisms. The first was by pushing a button. The second was by turning a potentiometer. In the first condition, pushing a button, you simply press the button when you thought that the color on the right matched the color on the left. For example, our subject here sees the color changing on the right, and when he thinks it matches, he pushes the button. Here's a recording of an actual trial. When the play button is pressed, you'll see the colors on the right change. When the colors on the right match the colors on the left, the subject is tasked with pressing the button, right about now. And an output is produced to monitor match accuracy. Here's a video recording of an actual trial. You can see the cardboard apparatus I used to minimize light exposure outside the laptop, as well as to split the vision between right and left sides. And shown here is that same cardboard apparatus splitting the visual field between right and left halves. We see a subject in the button condition matching colors right about there. And in the button condition, colors changed in a sinusoidal fashion as coded in Processing, and when subjects pressed the button, that stopped the trial. In the second condition, the potentiometer condition, everything was exactly the same, except you now had control over how the color changed by using the potentiometer. So now subjects had the potentiometer in the right hand, and when they thought the colors matched, they pushed the button with the left hand to stop the trial. So when Processing was played, the program would run and the color change was controlled by the potentiometer. As you'll see in the bottom part of the screen, I'm moving the potentiometer to match the colors. After the trial, performance can be seen, but only by the researcher. An interesting similarity between potentiometer conditions and button conditions emerged, where the subject would first climb above the match value and then go below the match value, almost as if to triangulate to the match value in a sinusoidal fashion, just like the button condition. In order to account for variation between sides of the body, I did run trials on the left side as well. So everything we talked about was the same, except the left hand was now in control of the button and the potentiometer. Processing was coded to produce a data file for each individual trial so that trajectories and matching values at the end of the trial could be analyzed for later use in statistical analysis. Using Levene's test for the homogeneity of variance, I discovered a statistically significant difference between the standard deviation of match errors in the button condition that exceeded the standard deviation of potentiometer conditions, again suggesting that potentiometer conditions were more accurate in their matching than the button conditions. Of course, more subjects and more data is needed before drawing any firm conclusions. The preliminary data is interesting at least. So, that's my project. Thanks to Dr. Jonas Rubinson for the equipment, the education over the past semester, and for adding this to my skill set as a researcher.